Yep.
So the idea today is that we just take it on to the next steps, because there's a little bit of time to be taken. I think, as I was saying the last time, probably the month of November, to get everybody comfortable with the idea of how it's going to work, comfortable with the idea of what you can get done in your own house, realistically, the idea of the costs, the idea of what it'll do for you, just to get not to rush into that, like to give it time, because the idea is that I would talk to everybody individually, just because everyone will have questions. So to give it time for people to be comfortable with that, and then when we get to December, and then be ready to go out to tender at that stage, once we know who's in and who's not in this particular wave. Now, one thing I'd like to say as well before we start off, all these webinars that we're doing and all the communications, you don't worry if you're not sure that you're going ahead with it or not. I've had a couple of people writing to me saying, I'm not sure now, maybe for financing, or maybe there's some work being done on the roof or something like that. So they're wondering, can they come to the webinar? You can come to the webinars, you can ask me questions, all of that communication side of things is all, that's, if you don't do it now, if you do it in a year's time, if you never do it, that's not the problem, okay? So and it always happens. We saw it happen in the last wave as well. You get a lot of people at the start, and then some people for different reasons. One couple had a baby. Now I suppose they knew the baby was coming. That wasn't that big a surprise. But so people drop out for different reasons, and we've got some people who dropped out in the last wave who are back in this wave. So feel free to. Don't feel pushed into having to make a decision thinking that start of December you won't be able to buy any presents for Christmas because you're spending all your money on photovoltaics or something, Now, the way I'm going to do it this evening, I'm going to leave the mic open. I think everybody's unmuted. Let me just check. Okay, we've got over 25 people in there now already. Let me just check and see if everybody is unmuted, because I want to leave it open this evening, because I'm doing a little bit of a presentation, which is a little bit of going over what we did before, but a bit more focused on the idea of getting ready for making a decision, And so I want people to feel free to pop in or to pop questions up on the questions and answers as well, or in the chat, any place, just so it'll be less. Maybe less structured as a presentation than the last time, but feel free to jump in. Now we're going to get through and cover the subjects that we want to do, which is basically the homework that I'd sent you out in the last email. There's a couple of questions, and that's how I'll be structuring the talk tonight, is answering those questions. So feel free to jump in. Now, if somebody is, I think you're actually able to unmute yourselves, aren't you?
Yep. We are.
Yeah. Okay, you have full control there. Grand job. Okay. So we have 30 people in there already. Now that's very good. It's very it's great to see the interest now. Okay, so we'll go through it, as I say. We're looking at the questions that I asked in the last email, the things you need to be thinking about to get comfortable with the whole idea yourself. So the agenda is going to be talking about the kind of things you need to be saying to yourself: current energy usage, because it's all about generating electricity. So this has to fit with your own usage or your own planned usage. So we'll just throw out a couple of things there. Okay, so current energy and future plans. We're going to talk about BERs again, because BER, very important part of the whole energy thing in terms of understanding where the energy is going in your house, and also kind of crucially, the BER is crucial in terms of qualifying for grants, the SEAI grants. And obviously, if you can get grants, then all the better, We'll talk a little bit then about roofs, about your roof, because obviously this has got to go someplace. So might do an example of just taking somebody's house and looking, having a quick assessment using Google Maps to do that. And then we'll go over a little bit again about cost and financing at the end, just so that people do understand what they're getting themselves into potentially. Like the prices I'll be giving, as I said the last time, the prices are based on the wave we did during the summer. Prices, I'm pretty sure, will have risen a bit. But they won't have doubled, but I'd say I wouldn't be surprised that we'd be looking at, kind of a 10%, 15% price rise. Because as well, not just the prices of materials have risen, but also I know the two installers we had, they cut it very tight on price. They were very, very good prices. And at some point, I suppose people have to make a little bget of a margin as well. So I would say the prices I'll be showing you again tonight will probably think in the region of 10, 15% more, just so that we, to get ready for that, okay? Now we can see that the map there, this shows where everybody is, or everybody, or most people, I think. Mostly in County Clare, I suppose that is the Clare Community Energy Agency. We're letting in the neighbours, from few people from Limerick, few people from South Galway. And again, there's a little tribe over in Kildare. We have 2 people actually from Kildare now who are interested. So we'll move along with everyone. Okay, so first thing, current annual energy usage. Talk about your energy usage first of all. So I suppose the first thing you need to be doing is getting your electricity bill. Getting going onto your online account, or if you have a smart meter, all the better. I hear that smart meters are being rolled out in Connolly next week. So they are being rolled out in different parts of the county. Much better in terms of being able to understand in more detail your usage, So, but you do need, minimum, you need to look at your bills for the last year. Okay, so the kind of things we're looking there is your total energy usage over the course of the year. And there's 2 things there. There's the amount of kilowatt hours that you use, and there's also the cost, just so that you understand the relationship between the 2. And then as well, having that for the overall energy, the overall annual figures, you then need also to figure out what is your seasonal energy usage. Now, by seasonal, I mean, what's the split between the winter and the rest of the year? That's pretty much it, because like we can see, we're getting into the heating season, okay? And the winter, it does change. Lights are on more often. We're spending more time indoors. We're using the tumble dryer a bit more, so you may have more. Well, you will pretty much definitely have more of an electricity usage during the winter. Now, I had this is a chart that was taken from. This is just showing. What we have here in blue is photovoltaic production. Yeah, because this is another thing as well. I've had a few questions, again, people talking about photovoltaics and heating, that they may have electric heating, or they may be thinking about a heat pump or electric radiators. I will say just photovoltaics doesn't match with heating, because heating, we're getting into the heating season now. The next 4 months are where we need the heat, or 4 or 5 months. Whereas if you look at the photovoltaics in blue there, that's really, you're not getting a lot of production in those 4 months. And that's just the way it is. Like, you could obviously vastly oversize your system so you're producing enough, but then that's, that wouldn't be an efficient way of attacking the whole thing. So I do say, and this is something, what I'm saying to you is, this is more the thinking you need to do yourselves, and the questions you need to come back to me with questions about this, okay? So get an idea of your annual energy usage. What we see in red there, the usage is, that's what's considered to be a typical home, not electric heating. This is with an oil burner or some other kind, but not electric heating. So you're just seeing that the change over the year is not massive, but you do have a marked increase at in the winter period. Just lighting, a little bit of heating, more time indoors. That's just the way it is, So you can see, just getting that idea of the match between your potential production, and your potential usage. Now that example there is for a 3 kilowatt system, which I suppose is at this. It's not a small system, but it's at the smaller end of the systems that we saw being installed during the summer. We had 3-4 kilowatts maybe, but half of the installations were 3-4 kilowatts, and then the other half were 5-6. That kind of size. Okay. Another thing, okay, when you're thinking about, again, I'm just giving you things to go on to think about, and questions, maybe get you to think about asking questions. When you're talking about the seasonal usage, okay, so you're seeing month by month over the course of the year, you've also got to look at your own usage and see day and night usage. If you do you have some? I'll give you an example. Actually, I'm not sure if the man in question is on tonight, but I was talking to somebody a couple of days ago who's in the group, and we were talking about his energy usage. He's quite high energy usage, and then it turns out a couple of things he was saying. Uses the tumbler dryer a lot. Like, okay, so that's fair enough year round. He was saying, and then he was also saying that he had was after putting in a new pond in the garden, with fish. In the pond, and the circulating pump in there, and lights there, which were going 24/7. Now the lights were activated in the darkness, so they're obviously being used more in the winter. But if you have anything in your house that's going 24/7, that's going to be, you need to think about this. This is something to identify. The man in question, he also mentioned one of his kids has, I think it's some kind of hamsters or gerbils or something like that, and they have a little heating mat to keep the animals at whatever temperature they want, which is on 24/7 all through the year. And it's a 100-watt heating mat. Now, 100 watts is not a huge amount of energy, but if you have 100 watts going 24/7 for the course of the year, every year you have 8,760 hours, so 100 watts would be 876 kilowatt hours per year. Okay, not far off 1,000 units of electricity a year. So if you have those kind of loads in your house, you do need to, it's important to identify that. Like in one case, also to say, well, if it's on the whole time, and if I'm going to keep the hamsters, we're going to keep them heated, so that will be on the whole time. You're saying you then have a base load that you have that 100 watts, which is on all during the day. And then you could say, well, then my photovoltaic system, I know there's a minimum of 100 being taken off the whole time. And this can have an impact on, for example, the size of battery that you might be putting into your installation, or the size of the installation itself. But particularly maybe the battery could become, if you have permanent load like that, you may not need as much the same size battery, or, that's something to take into account. Okay, so the third point that I have there, so the first 2 points, this is for you to go and think about your house, think about your energy usage, get your figures from your electricity provider, and to see where are the big, if you can try and identify what the big the big loads in your house are, and specifically the always on loads, if there's something that's always on. Okay, and then third point there, and this is the most important thing before you size any product, any project, can you reduce your energy usage? Now that you've thought a bit more about it, are there things you can change? Because it'll definitely be, whatever you can invest in energy reduction will save you money. It's the best time to, rather than spending money on a bigger photovoltaic system, spend less of that money on reducing your energy usage, and it'll be, things will work better. Efficiency is the first angle to take on this. Okay. Right. Now that third slide there on the thing, this is just showing, it's going back to the notion of variability of photovoltaic production. There'll be some days, this is an example of a Monday and Tuesday, when was that? That was before the summer, in May, I think. And you can just see from Monday to Tuesday, for you, it'll probably be 2 working days, same things going on, kids going to school or whatever, same kind of activity. But the 2 days can change dramatically. So it is, I suppose, in terms of your energy usage, this again is kind of all informing you understanding what is your energy usage on a daily basis, and also taking into account that you do have a high degree of variability in your photovoltaics, which again leads into the question of, do you need a battery or that kind of question. Okay, let me, and we'll do actually, now that that's talking about energy usage, does somebody have a few questions on that now? Maybe if we go through, we have 4 or 5 sections, we can take the questions as we go through. So anything, any questions on the usage? Have people been able to find their bills, or anybody already have smart meters and looking at their usage through the smart meter portals? Or are people quite, consider they're quite aware about the amount of electricity they're using every year? Is there someone coming in and out? Yeah.
It's Jason. Just talk us through what process you would have for whether you're going to use a battery or not. What does that hinge on?
It hinges on the size of the installation you're putting in. Okay. Like the only system I would say where you don't put in a battery is where you're putting in a small system, a 2 kilowatt or a 3 kilowatt system.
Okay.
Like in a typical house, just this is the figures that go along there. If you have a typical house, will take about 1,800 or 2,000 watts, kilowatt hours from any photovoltaic system. So if you're putting in, 1,500 kilowatt hours from any photovoltaic system. So if you're putting in a 2 kilowatt system, for example, that's going to produce around 1,800 kilowatt hours during the year. You can be pretty sure that of those 1,800, 1,500 you're going to use in the house. And then the other 300, that would be the argument for the battery or not. Whereas if you're increasing the size of your system, if you're going up to a 4 kilowatt system, you're now producing 3,600 kilowatt hours a year. The probability is, because of the whole notion of variability, that you will still only be directly using 1,500 of those units. So the risk of loss, we'll say, or not getting the value from your solar installation increases as the installation size increases.
Okay.
Okay, but again, obviously, depending on a particular house, if someone is saying you've got a permanent a base load on the whole time, that could change. Somebody with a series of pumps or lights or whatever it may be that's running full time. If somebody's running a server or a bunch of servers inside in their home, or for whatever other kind of idea, that could change. But typically, I would say once you go beyond, and that's actually the way the grants are organized as well from SEAI. You get a big grant for the first 2 kilowatts. You get €900 per kilowatt. And once you go beyond that, then they will only give you a grant if you put in a battery. And that's the reason. The reason they do that is because it would be wasteful. The SEAI want to push you to using as much of your own electricity as possible. They don't want you to be using a small amount, pumping a lot out onto the grid, which may not be at the time that the grid necessarily wants it, or can, well, okay, not can handle it, because it wouldn't be a huge quantity. Okay.
And so, on that basis, like, how would you size your battery then?
You'd size your battery on. There's a couple of things, I suppose, and there's a couple of functions for the battery. One of the main things about the first thing about the battery is you want to avoid wasting your electricity. You want to use as much of your electricity as possible. So what you'd look at then is you'd look at what is your average daily electricity usage. Another question that comes in there as well is the second function of a battery backup is not just using your solar electricity, but also giving yourself backup in case the lights go out, in case there's a power shortage. And then the question you ask yourself is, well, do I want to give myself a day? Do I want to give myself 2 days? Because typically the sizing of your battery would be less than an average day's usage. If you're using on average 10 kilowatt hours a day, you wouldn't be putting in a 10 kilowatt hour battery. You'd probably putting in a 5-6 kilowatt hour battery. That's kind of the way in terms of just pure efficiency. So like in that situation, you'd be saying, okay, in the case of a power outage, well, I'll have enough power that'll get me through a day. I can always, kind of turn things down, but it'll get me through a day, but it won't get you through a month. So you're not looking at a kind of an apocalyptic situation. Can we last 6 months until the army gets here? You're looking really at that short term. But then again, some people say, well, I would like to have a little bit more resilience built in, just so if it went down for a couple of days, 3 days, or whatever, that I would have. So that's it comes down. Every installation, there's kind of different things going into it. But typically, as I say, you'd size your battery a little bit less than your average daily usage.
Okay, thanks. Thanks, Con.
Okay. Now, let me see. I'll just go through a couple of these questions now, because I presume these are, smart meters. Not for subscribers. I heard that, yeah, Kevin, that they were smart meters, not if you were doing night rate. For whatever I don't know what the logic behind that is, to be honest now, Okay, the day-night break, Niall. Yeah, if you don't have night rate, then you won't be getting separate figures for your night rate. So I suppose it's up to yourself to understand the kind of things that are going on, like if you've got a timer on your immersion or that kind of thing. Now, Paddy's saying use about 15,000 units a year, 10,000 day, 5,000 night. Air to water heating.
So they're all the same, aren't they?
I think, Jason, I think is your mic on there? Is that you? We can hear. Okay, so about with an EV and an air to water heat pump, then that's okay. You can see in the spread. You can see the figures. Oh, actually, you can't, can you? There's Paddy was saying there he's used about 15,000 units a year, 10,000 per day, 5,000 per night, but he has an air to water heat pump and an EV. Now, the EV typically you would say is probably being charged on night rate to get the best value for that. And then 10,000 during the day, a lot of that would be coming from your heating, from your air to water heat pump. The vast majority of that, I'd say, is coming from your heat pump, yeah. Okay, now 210 bill every 2 months on average. What's the number of panels we'd need? To be honest, you'd need to switch that to kilowatt hours. You do need to think in terms of kilowatt hours, okay? It's not in terms of cost, because depending on your electricity supplier, you may have a higher or lower cost per kilowatt hour, a higher or lower standing charge. So you just need to look on your bill, and the bill will give you the figures for the kilowatt hours that you're using, okay? So if you want to get back to me on that with a figure on kilowatt hours rather than a figure of cost. If you get extra, can't I just pump it into the grid? We'll talk about that pumping into the grid in a while, okay? We'll get onto that. When the battery is charged, will the house draw on the battery automatically until it is used up? It will. You set up, the inverter is the brains. The inverter is the box that does all of the clever, deciding where the electricity is going to come from the house. Okay, so it will decide if the battery. Now you can also program the. Again, like I said, the inverter is the smart energy management system. Somebody mentioned that term to me during the week. And it's what will decide when the photovoltaics is coming in, whether how much do you want to send to the battery? Do you want it going at particular times? Do you want something going to heating your hot water at certain times? The inverter is programmable, and it'll be up to you then to set that. But again, these are the questions that would come in when you're buying an inverter. There will be a question of, there are different levels of control and programmability. So that's something that would come in there, depending on how complex the system you wanted to set up, okay? Now, Catherine Webster, spec quite low, 2.4 last year, overspec with 3 kilowatts. 3 kilowatt hours you'll produce. Now, when I'm talking about a perfect south-facing roof, we'll talk about roofs in just a second. That would produce 2,700 units a year. Okay, so if you need a battery system, a small battery system, to make sure you were getting the value for your, actually maybe even you wouldn't, to be honest, at 2,400, you could possibly just go on using directly. Maybe you need to have a talk about, what your kind of rhythm is, if whether you're home during the day or not, and then think about the feed-in tariff. For whatever you don't use, you'll get your 10, 12 cents a unit on that we'll talk about in just a moment, okay? Now, I'll get back to the questions again in a while. Okay, I just want to move on to make sure that we get through the rest of the rest of the items we wanted to cover here. Okay, so future plans. Okay, this is some people mentioned these different things here. To see, one thing is to say this is our current usage, but you've also got to think where are you going, and where you're going. Does that actually fit with the idea of photovoltaics? The two things there, the big add-ons, the ones that are very topical now, are EVs and heat pumps. Okay, now in terms an idea of the scale of energy that would be used for either one of those. EVs use about 1,500 kilowatt hours per 10,000 kilometers. Typically, you'll see on most EVs that I've tried, they all seem to be around that 15 kilowatt hours per 100 kilometers. That's the equivalent of the miles per gallon or the kilometers per gallon that you get on EVs. So, now, having said that, let's say you're driving 20,000 kilometers a year. That's 3,000 kilowatt hours extra usage in that house compared to a house without an EV. It probably does make more sense, though, to buy that from Nitrate for a couple of reasons. One is just straightforward cost. Okay, it's your electricity is cheaper. The second one is as well just to. You have to remember that EVs are very, very big batteries. That's what they are. Like a typical EV you're buying these days is about 45 kilowatt hours, maybe 60 kilowatt hours. In terms, if you're talking about something that has 300 or 400 kilometer range, these are very, very big batteries. And there's no way, just to give you an idea on that, I have a 3 kilowatt system installed on a house here nearby. And that produces, on the best day, I looked at the best day this summer, and that produced 20 kilowatt hours. On the finest day in August, whatever it was, there was some Monday, it was a perfect solar day. So that's on the best day, it'll produce 20 kilowatt hours. So I think people should, first of all, get away from the idea of thinking they'll be able to fill their battery and their EV with their photovoltaic system. That's not really a runner. Like, it'll be topping up away as you're going during the day, but because of the variability, you won't be filling your EV. You'll be kind of topping it up a little bit during the day. But it's just such a big battery that it's difficult for photovoltaics to have a major impact on that, which is why I kind of say the EVs, often the major part of the consumption is coming from nitrate electricity, which is fine. That makes sense as well. Heating requirements, heat pumps. Two things about heat pumps. One is they use a lot of electricity. Now, that figure that I have there, the average Irish home uses roughly 10,000 kilowatt hours for heating. That's not heat, that's just in terms of the energy that it uses. If you had a heat pump, that would be, of the 10,000 kilowatt hours of heat you'd be using about 3,500, 4,000 units of electricity. The idea of the heat pump is you get this multiplier effect. For every unit of electricity, you will get 2-3 units of heat equivalent. That's the idea. But the other thing about heat pumps that I mentioned earlier on as well is that heat pumps are primarily going to be running during the winter. And that doesn't really match with the photovoltaics. Now, the one case where a heat pump is a good match with photovoltaics is if you are using the heat pump for heating your domestic hot water. If you don't have like a solar thermal on the roof, and you're using your heat pump for that, which is a good thing to do with a heat pump, because it is a very efficient way. It's like 2 to 3 times more efficient than using an immersion to heat your hot water. So in that sense, it can match. You could set things up so that during the day you will, on sunny days, or when the sun, in the 6 months where there's the most sun in the year, you could organize your timing so that your photovoltaics would be heating your hot water via the heat pump, which would be a very efficient way of heating hot water. Okay. Again, the third point there, though, is from a heating perspective, the first thing to think about is how can you reduce your heating requirement. So in terms of insulation, in terms of draft proofing, in terms of thermostat controls, these are kind of the cheaper things you can do that have a good impact in terms of reducing your energy requirements. They would be the 3 things, like I said, thermostats, attic insulation, or insulation in general, and draft proofing, draft controlling your house. Okay, now, so that's future plans. Now, okay, let me go and take a couple of questions here before we go on to talk about the BER, okay? If the grid gets under pressure, we get rolling power cuts. Can you make sure your battery's fully charged if you know you're due to have a power cut, even if you charge it from the grid? Yeah, you can. I told the story last week in the webinar, or the week before, about a guy in Newmarket who he had the installation almost done. They just had to do a little bit of connecting up with the wires. He gets a letter in the post saying, grid's going down next Thursday for 6 hours. And he called the installer and said, listen, can you get it done? And they got out on the Wednesday, and they got it done. And you can ensure that your battery is full. If you know it's coming, you can ensure that it's full. You can do, like, your inverter will allow you to do that, even whether it's coming from the photovoltaic, or also you have a thing called forced charging, or you can do night rate charging on your battery so that you can charge up your battery at night and then use that electricity during the day, whether that's just for your morning usage or whether you're getting ready for a potential a planned outage. Okay, now Mike Hogan, currently using 3,600 kilowatt hours a year. I heat my immersion water from my oil heating system. Am I better to go solar panel for hot water and keep my central heating on the oil? Now, okay, let's see. You're heating your tank from your oil heating system. Solar panel for hot water. Okay, I presume you're talking about solar panel, the photovoltaic for the hot water.
Yes,
because you can get these things called a diverter, hot water diverter, which will allow you. It's a good idea in terms of not wanting to waste your electricity. You can turn on you're turning on your immersion kind of for short periods of time at low powers, just to make sure that there's no energy being wasted going onto the grid. With the question of the feed-in tariff coming in now. Like the idea of the hot water diverter being that you avoid wasting electricity going out onto the grid and getting no value for it. With the feed-in tariff coming in, it mightn't be as, the feed-in tariff is probably a better deal cost-wise. Unless, of course, you're going to be, that you have your immersion timed to be heated up potentially during the day, when you potentially would be paying full whack from the grid. That 20 cent again. So there's a couple. Like, there is an argument to be made for a hot water diverter for heating your water. Again, depending on your needs. But the feed-in tariff does change that a little bit. So that's something maybe we could talk about, Mike.
Yeah. Okay.
Again, yeah. Okay,
Great.
keeping your central heating on the oil. Well, yeah, like I said, yeah. If you're not swapping out the oil boiler, then your oil boiler will keep on providing your heating, and that keeps working away.
Longer term, I'd probably go on the change from the oil boiler to the air to water system.
Yeah. Okay. Now, I think this is just an opinion of mine, that there's a big push on from the government about heat pumps. It's kind of heat pumps, and you hear it on the radio, you see the ads. There's a big push on it, whereas really the biggest push should be on insulation. Because it's getting your usage down. For a start, it's cheaper. There's no question about it. And that's where you need to go, rather than, you'd almost get the impression that the push is on to put in a heat pump no matter what. Whereas really, if you bring down your usage first of all, well, then if you have an oil boiler now, and if you can reduce your oil consumption by 30%, 40%, well, that's great. That's a result, like, you know.
Yeah. Okay. Very good.
Okay. Now let's move on to the next topic. Now, next topic was the BER certs. Okay, the reason we're talking about BER certs is if you want to get an SEAI grant, you will need a BER cert. Okay, so the BER cert is proving the energy performance of your home. That's what it does. It tells you whether you're good, bad, or someplace in between. Now, specifically for the photovoltaics, what you need to do is the condition for the grant is your home needs to have a BER C3 rating or better after the installation. Now, when you get a photovoltaic installation done, that will improve your BER rating. It'll bring it up by a bit. Now, typically, I think I got some figures there last year where 3 kilowatt system. Now, again, this obviously depends on your starting point. It depends on the size of your home. It depends on the size of the photovoltaic installation. But just to give you a rough idea, that a photovoltaic installation, a 3 kilowatt system, we're talking about 120 square meter house. Like not a huge house, but not a small house either. And that was going to have an effect of between 30 and 40 in terms of the rating for the BER. Just what that means, if you can see these BER ratings here, like to get from a D1 is from between 260 and 225. So if you're in a D1 and you get your photovoltaics put in, well, that's pretty clear. That's going to bring you to into the C3 territory. Or better, you know. So it does. While you need to get to the C3 after the installation, the photovoltaics will bring you in that direction. Okay, but it depends. Obviously, the bigger the photovoltaic installation, the more impact it has on your BER. Okay. Now, what I do recommend to people, if you have a BER already, well and good. If it's recent and if it had identified things that could be done to improve it, but at least you know where you stand at the moment. If you have a BER already, if you don't have a BER already, I would recommend getting one done. You know, get the BER, the assessor out to do it. I would say, you know, pay the man, pay the woman, but say to them you don't want it published, because the idea would be when they do the BER initially, what they're going to say is well, okay, you're a D1, or maybe they'll say you're a C2 or whatever, and so you're grand. You know for sure that you're getting your grant, but don't publish it until afterwards, because the obligation is the BER is published after the installation. So I would say, you know, get the BER man out, get the report done, see where you are, see where you stand. If there's something else you may need to do, improve your attic installation, whatever, you know, they will give you kind of indicators of where you're slipping up, and then just say, well, let's just hold off on publishing it. We'll publish it after the installation is done, and then that'll do, instead of paying for a BER twice, basically. Now, costs around 350. Again, that is variable. You can get it for less. Some people will charge more. I would recommend call a few people, call 2 or 3 people, get prices from 2 or 3 people, and go with that. Now, that link that I have there, let me share this link with you. I'll put it up there on the chat. If you want to click on that link, that will open up. It's a map of Ireland showing all the BER assessors in Ireland. Okay, so you can zoom in and just basically, it's a little bit of a help to try and find someone that's closer to you, or someone that's in the area, or to get an idea. You know, it just gives you an idea of who is where, depending on where you're located. Obviously, in the towns and the cities, you have a lot more. But you know, if you're out, we have let me just go back actually to the spread of the people that are signed up for the moment. Like, it's not. And I think actually, you know, we saw this the last time as well. It's mostly a rural. You know, there aren't that many people in towns that you can see over here. We've got a little bit of how do you call it? A hub, cluster, a cluster in Lahinch, Liscannor, Milltown, that kind of area there. We've got over on East Clare. They're always over in Scariff. They're always mad for the solar over in Scariff and in Killaloo down there. You know, so it's not so much urban. It's more, I think, you know, it's more of a. I suppose people have space. Maybe the houses are bigger out the country as well than in town or something like that. Now, so where was I? I was showing you the map. There was the map there of the BER. Let me just get this. That just has the contact details for all of the BER assessors in the country. Okay, so if you want to just get in touch with somebody, you've got the phone numbers, you've got the email addresses there. If I can find it, yeah. So if you click on any of those points, That'll give you, it gives you the contact details there. So depending on where you're located in the county, I would say call 2 or 3, have a chat with them, see how you feel about them, ask them about the price, have just a quick description of the house, and then take it on from there. I don't make any particular recommendations, okay? Right, now back to, let me just see how we're doing there. Okay, so BER, yeah. Now that map, all of those, they're all SEAI registered. Okay, I just pulled that data down from the SEAI website, so they obviously have to be registered to be, to count in terms of grant applications and that kind of stuff. Okay, now next thing, the roof. Okay, I suppose when it gets down to it, at some point it has to get installed someplace. Now we'll talk about the roof first of all, and then I'll talk about the idea of, I got some more information on ground mounting systems as well that I'll talk about afterwards. So first thing is, yeah, you've got to look up at your roof and you see where can it go. Where can it go? Now, one of the good news, the bits of good news about this is you don't necessarily have to have the perfect south-facing roof at exactly 30 degrees. Now this, let me zoom in here a little bit just to show you what this image is about. What this chart shows you, it allows you to calculate the efficiency, roughly the efficiency of where your installation would be, even if you don't have a perfectly south-facing roof. Let me zoom in here a little bit more. No, not that. Okay, so what this is showing here, no, that won't work either. Okay, on this chart, what it's showing is the number inside in the dots shows you the percentage efficiency that you will get depending on the way your roof, the orientation and the inclination. So the orientation is whether it's facing north, south, east or west, and the inclination is the slope of your roof. Do you have a very steep slope? Is it a flat roof? That's what the inclination is about. Now, let me see if I can scroll down here to make it a bit easier to see. Okay, so what we're seeing here in the center, where we have 100, right, which is your perfect efficiency, that is if your roof is facing due south. See up here, you got 0 degrees, and if the slope of the roof is 35 degrees. Okay, so that would be the perfect situation. Now, the reality is the vast majority of roofs are not 35 degrees. I think they're more between 25 and 30, something like that. The vast majority of houses aren't facing perfectly south. But by looking around, like if you look at your particular house, let's say you're 30 degrees off to the west. So what you do is look down the line here, and then look for the inclination that corresponds to your house, 20 degrees or 30 degrees, which is a more typical kind of Irish house there. And you can see instead of being 100% efficient, you're 95, 96% efficient. So the loss is, it's not huge. Okay, we won't say negligible, but it's not, you're losing 3-4%. It's not the end of the world. But what I really like to look at here is that when you go even further out, like go 45 degrees off. So imagine your house is facing like southwest or southeast, and it's again typical slope. You're between 92 and 94%. So again, the loss it's not dramatic, because I do have some people, from talking to people, it's kind of, oh well, yeah, my house is not facing south, so it's not going to work. You can see from the figures here, it's not a dramatic loss, and it's very rare that people have perfect houses. And actually, one thing I find curious here is if you go to even as far as the 90 degrees east or west, see there the minus 90 or the plus 90, with a standard slope, which is 30 degrees, 20, you're still getting 80% to 84% of the production. So like all is not lost. There can still be a case made for putting even on a roof facing due west or due east. Now it's rare enough that we have that kind of situation. We did have one during the summer, and in that case, the man, he put some panels on he had an A frame, which was the A was facing due south, and he put half of the panels on the east, half of the panels on the west. So he's generating more in the morning than he would with a south-facing system. He's generating more in the evening than he would with a south-facing system. He oversized his panels slightly. He didn't need to oversize his inverter, so he didn't have an extra cost there, because the two panels were never producing, the two sides were never producing at peak at the same time. And he got a good system, a pretty good system. So it's all is not lost. If you've got only a north-facing roof, like at 60 degrees, okay, maybe that's problematic, but that's very, very rare. Okay, now so on that screen, there's a link there. to this tool. I'll share this with you. I think it was in the previous slide as well. The PVGIS tool, it's an online tool which will allow you can put in your specific location, you know, your pick your location on a map. You can say the orientation of your house, and it'll build basically this chart. It'll give you the actual percentage output, the number of kilowatts. You can also put in the size of potential installation, and it'll tell you how much electricity you think you'll produce during the year. Okay, so this is the story about the roofs, but you do need to think now when you're looking at the roof, and when anybody who calls me up, what I do, I suppose, the first thing I always do is I go on to Google Maps. You know, I have your air codes. You can go on to Google Maps. Do I have an example here? Yeah, this is an example of, this is actually my house seen from the sky. So in there, in Google Maps, you can actually measure. Let me go in and create a map, and I'll show you what you can measure the width and the of your roof to get an idea of what the surface area is. Now, I suppose most people will have an idea, and it's not that big a deal to go with a tape measure and to get an idea of the space available on your house. But if you zoom, let me see, where are we? Let me zoom in here. So you find your house, and then in this tool, in the Maps tool, you can just measure. With this tool here, you can measure the width of your roof, and then you can go down, you can measure the area of the full roof. Now you can see there I have 2 dormer windows, so it's not a great roof. And it'll measure the surface area of the space that you have selected there. So that's saying 40 square meters. That's the equivalent of 0.004 of a hectare, okay? Now you have to remember, if you do use that tool, what that's showing you is as if you were looking down vertically from above the house. Because your roof is sloped, let's say if you're at a 25-degree angle, you can add on 10%, roughly 10% onto the surface area. So if Google Maps there is telling you that it's 40 square meters, it's actually 44, 45 square meters, just in terms of being able to size to see where you can fit an installation. Okay, so that's a pretty useful Google Maps that's how I start off. Now the installers will have a different tool. There are more professional tools which will do, you know, far more detailed analysis. But even just looking at Google Maps, you can get a good idea of what's possible and what's not possible. Okay, any questions there about the roof side of things? Let me just drag my. Okay, now we'll move on. The other issue, yes, ground mounted. Some people have been asking me about the potential, you know, you may have a house that you'd prefer to avoid doing something with the roof, or it may not be oriented correctly, and you may have some land available. We had one guy did a ground mounted system over around Scariff in the last wave. Now, it did take him a little bit of while. As I said to him, he was kind of the first soldier out of the trenches because it's not the most common thing. The most common installation is just on the roof, and a roofer will do it, like, you know, and it's actually the difficulty was just finding the material, finding the actual kit that is that has the it has to be licensed. You know, it has to be you can't do it yourself basically. And the kit that he ended up finding cost about 1,500 euros. This is for a 4 kilowatt system. Okay, and it basically is it's a frame. I'm not sure is it galvanized steel or an aluminium frame that the panels go onto. Now he did a little bit of civils in terms of pouring a bit of concrete pads for putting it there. But just to give you an idea of the cost there, I thought initially it would cost less than that, and I thought there was more possibility for doing more DIY. But the installers, they have to give the details of all of the products that are used in the installation, even down to the mounting systems. So you can't lash it together yourself with a bit of 4x2. Now, obviously, when you do that cost, you're saving yourself the cost of the roofer, and the roofer cost is coming in, like we were seeing, any of the installations that were about 6,000–7,000 euros. The roofers were taking 1,700–1,800 euros out of that. So you do avoid, you know, if you do have, it is possible to do a ground mount system. We do have this experience now of this kit, and I checked actually a couple of other kits since, and the prices all seem to be about the same, around about the 1,500 euros for a 4 kilowatt system. It will mean you'll do a bit of digging yourself if you're happy to do a bit of digging. If you want to get the installer to do it, that'll be, you know, there'll be a bit more of a cost there. But I suppose what I was trying to say when I was talking about the roofers is there isn't a huge cost saving by going for ground mounted. Okay, it's pretty much instead of paying the roofer, you're paying more for the mounting system, possibly for a bit of civils as well. But it is possible to do it. There's no problem. It's there's nothing more complex to a ground-mounted system than a roof-mounted system. Okay, now let me see. How close to the edge of the roof can the panels go? I don't know. I can't give you a figure. I know the planning regulations are in the process of changing at the moment. Okay, so there will be something coming out. It's been relatively loose. Like the planning regulations up to now were that you could put a maximum of, I think, 12 square meters. Yeah, 12 square meters of panels on your roof, which was happily ignored by every installer across the country for the last few years, and there have been no cases that I'm aware of people getting into trouble with planners over that. It just everybody seemed to agree with the idea that this was going to change, and the legislation is on its way through. It's on its way through the Senate now, and it's gone back to the Dáil. It'll be a few more months before it comes through, and that will give a bit more details about in terms of close to the edge. Now, I've seen installations where this is just purely from safety on the roof point of view. You do need to be able to get around the panels. You know, for whatever reason, somebody needs to intervene on the roof. You need to be able to walk across the top. You need to be able to walk down the two sides. You need to be able to walk across the bottom. That's just from a pure safety point of view. So you will be talking about leaving maybe a meter, that kind of thing, around the panels, just so you can get access to it. And even from an installation point of view for the installers, they'll need that as well. So close to the edge. Now, obviously, I've seen people putting panels on sheds where the sheds have been sized specifically for the photovoltaic installations. And in those cases there, you know, where it's not up, you're not talking about scaffolding or being up on a roof, where the shed, all of the roof is accessible from a stepladder or something like that. Then I've seen the entire roof covered with solar panels, because you don't have that issue of, you know, it's not being installed on slate or tile where you may need to get up on the roof for some other reason, okay? Now, Graham Lightfoot, we have a 2-story building adjacent to our house to the west. So it will block the sun during the afternoon and the evening. Okay. I suppose you'd have to look at how much of an overshadow, you know, you need to go and look at it. Obviously, yeah, it'll have an impact. Like if you do have something that's close to your house and that is substantially higher, then obviously what you would try and do is on your roof, you would try and move away from that. So if you have a shadow coming from the west, you try and move your panels as far to the east as possible. It would again depend on the actual orientation of your roof. Is it due south now, or is it slightly east or west? Because that would have, you could look at that. It will have an impact. Yeah, that's for sure. We can do rough calculations on that. Typically, when the installers get out, they will have tools like PV-Sol or the professional grade ones, which will be able to take into account all kinds of shading. It is something, you know, when we talked about the step of talking to the installers, we'll be doing it as a group, but I'm also giving people the option of going individually to installers in the region. Just to, you know, call them up, get a price, discuss the way it would be done if the solar Meitheal wasn't being done. And there is no, you know, we're not stopping anybody from, if they have a particular good contact, or if they've had a particular good news story from one of the installers, from their neighbor, from their sister-in-law or something, then, you know, there's no difficulty going with the installers, with some other installer that you find yourself. But like I said, the installers themselves would be able to run a simulation in their software and include the idea of shading, be it trees or be it buildings nearby. But they'd obviously need to come out on site to see that, you know. So that's probably if you've, you know, after the telephone call, if they wanted to come out and visit. Okay. Now, with someone there, garage roof is 20 meters from the main house. Will we lose a lot of charge bringing it in? It's a question of the section of the cable that you use. You need to run a cable specifically. So if it's just a question of sizing the cable correctly, and then there isn't an issue of loss for 20 meters, you wouldn't need to worry about that. Okay. What sort of costs are the batteries? Now, actually, what I'll give you, I'm going to give you a couple, just to give you a baseline cost. I'm going to give you a few addresses of wholesalers. Now, when I say wholesalers, they'll actually sell to the general public as well. But these are the people who will sell. If you want to buy a kit and put it up yourself, they'll sell the kit to you, okay? So let me give you, I have 2 links off the top of my head now. So Solartricity, first of all. They're probably the longest established company doing this. Okay, so let me give you their address there in the chat. That's one. Let me see now, where did I think it was Midsummer, yeah, midsummer.ie, who were a similar kind of an operation, just maybe not, a bit more recent. Okay, so both of those, if you want to get in terms, if you just want to understand materials costs, either of those websites will, let me go back onto the Solartricity one, I'm just more familiar with it, okay? So if you go in, look for products, look for battery storage options, click on battery storage options, and I believe it will give prices. So whatever range, now obviously every supplier will have their own particular ranges. So let's look at the Pylon Tech. And okay, so what it's saying there is this model here, 2.2 kilowatt hours usable, will cost 838 euros. Okay, and then 3.6 will cost you 1,200 euros and so on. And they probably have the other brand they do probably is bigger. Yeah, 5.3 kilowatts for 2,000 euros. Okay, so that just gives you, I'm pretty sure those prices, yeah, are ex-VAT. Let's just add on your VAT onto that. One thing in terms specifically to batteries, like for example, Catherine, you have a small installation you were talking about. If you were going for the smaller battery, you're 838 euros. Let's say that's 1,000 euros, including your VAT. You get a 600 euro grant for the battery. Okay, so it's going to end up costing you 400 euros in that case. The 600 euro grant is independent of the size of the battery. So if you're putting in a 10 kilowatt hour battery, it's still a 600 euro grant. Okay. Now back over here. Okay, a little bit again, just a couple of figures on cost and financing. Okay, the costs. These are the costs again coming from wave one, right? First of all, over here I was breaking down how you'd looking at where the costs come from. In general, about half of your cost is due to installation, between the roofer and all the electrical works. Now, when we say the electrical installation, that includes the wiring and all the bits and bobs as well. And then the other half then is your inverter and your photovoltaic panels. The curious thing is, like, the panels are not the major item. The things that are actually producing the electricity are not the major cost item. And then your options, then batteries, the kind of costs we saw there, and then a hot water diverter. Typically, hot water diverter comes in about 400, 500 euros. When you're getting installed at the same time as you're doing the other panels. Okay, and the kind of costs we had here, we did a bunch of these systems, 6 kilowatts, 5 kilowatt hour, some with hot water diverter, some without, and they were roughly coming in at about 10k before the grant. So you'd be taking 3k off that, 3,000 euros for the grant off that. So around about 7,000 euros for a 6 kilowatt hour system. Now, again, I would caution that price will increase. You know, we won't be getting those kind of prices. So I would think, now again, we'll see, the proof of the pudding will be when we go to tender, but I would say we'll be coming in around the 11,500 for that kind of a system. Okay, and then your 3,000 euro grant taken off that. Okay. The other example down here, 3 kilowatt system. This is a 3 kilowatt system with no battery, just 3 kilowatts. Cost 4,500 euros. Now, I gave the example here of if you were to get the grant, you would only get the grant on the first 2 kilowatts if you're not putting in a battery. So that would be 1,800 euros, which would bring your cost down to 2,700 euros after the grant. Now, the person in question who put in this was the smallest system without a battery, wasn't actually getting the grant. The house was built after 2011, or it was built in 2011, but didn't qualify for that, didn't qualify for the grant. And they were happy to say 3 kilowatts, 4,500 euros. It was a good price, and they were happy to go with that. Okay, so that gives you an idea of the kind of prices we were getting. Now, in terms of the grants, okay, so that's just going over that link there. Will give you the link to the SEAI page that talks about the grants. But just the summary is, first of all, it's given on a per kilowatt basis, which is the size, the potential output of your system. The first 2 kilowatts gets you 900 euros per kilowatt, and then for the next 2 kilowatts after that, you'll get 300 euros per kilowatt. But you do need to get a battery. Okay, and then the battery is 600 euros for the battery. So the maximum grant you can get is 3,000 euros. Okay. The other thing, we'll call it the great unknown. For the moment, the feed-in tariff is coming in by the end of the year. The idea being, instead of wasting your electricity or instead of having hot water the whole time with a hot water diverter, you can now get paid for whatever electricity goes back out to the grid. We're hearing around 10 cents, 10, 12 cents per unit. And that little calculation that I did there was just to show, if you had a 3 kilowatt system producing 2,700 kilowatt hours a year, if you were using 1,800 of those, so you're avoiding paying 20 cents for each of those units, that's worth 360 euros a year to you. The 900 you're exporting, you'll get then, now I'm not sure the actual details as to whether it's going to be just kind of reduced from your bill or whether it's going to be a check given to you every year. But that would be the equivalent of about 100 euros. So you're talking about 450, 460 euros payback on your 3 kilowatt system, which cost, in that case there, which cost about 4,500 euros, which is, that's without a grant, you're getting about a 10% payback in that case. Now, okay, what have we, I think we've gotten through, okay, we've gotten through everything, okay? Let me go back and see a couple of more questions that have come in, and then we'll open it again. Okay, how many panels and space would you need for a 4 kilowatt setup? The number of panels depends on, panels now typically are about 350 watts, between 350 to 400 watts. We can see they're progressively, over the years, they're progressively getting bigger. So if you're talking about, like maybe a 12 panel system, so the layout is usually quite flexible. They might do a 6x2, they might do a 3x4, 4x3, depending on, the orientation and that. The space requirement is per kilowatt, it's between 5 and 6 square meters per kilowatt. So a 4 kilowatt system would need 22, let's say 22 square meters on your roof. Okay, are grants available to businesses as well as residential installations? I'm not actually working with businesses for the moment. Okay, so I won't give you, I won't pretend to give a comprehensive answer on that. It's something I'll be looking into. Like, there are grants available for businesses. Like, I do know of one company that someone in the family has one, and they were getting grants from the local enterprise office, which is going to cover about 35% of the cost. So there are grants available, but it's not the same. It's not the same program. One place where it is within the same program is the grant scheme. There's a community grant scheme with SEAI. Now that is kind of going beyond. It's like the Solar Meitheal Plus, where in a community you would have, where you get a group of houses, some community buildings, some businesses, a mix of the community. That's what they're looking for. And in that case, there would be 35% grants for photovoltaics as well. So, but it's a different context. Okay, I won't say more about it because I'm not fully au fait with it. Okay. Now, Emily, with a question there, could we put the inverter and battery in a shed which adjoins the house? Absolutely. Yeah, the inverter and battery doesn't need to be. There's quite a bit of flexibility in the location. Obviously, the idea would be that you get it as close to the panels as possible. We don't want it too far from the panels. And then coming out from your inverter, you just run the right size cable to your distribution board, and then that's in terms of losses, it's not something to worry about. Okay. Now we had Dawn, valuable site to give an idea of daily solar. Okay, that's similar to the PVGIS page, is it? I'll stick it up there. Forecasting real-time irradiance. Okay, yeah. All right, good. I'll share that when I send out the link. I'll update the presentation with that as well. Okay. All right, cool. Now we had a question there from Graham Lightfoot. Annual usage last year was 8,000 kilowatt hours for an all-electric house, including heating. Okay. The split was roughly 50-50 for day and night, which we can't understand as we only have a small storage heater and the hot water tank on night time only. Okay. Now, I would say 8,000 kilowatt hours, including heating, is quite low. So I would say either your house is very well insulated, or your thermostat is working very well, or you have a nice selection of woolly jumpers. 50-50 for day and night. Yeah, okay. Small storage heater, like your heater will take quite a bit from it. A hot water tank. It's something we can talk about specifically. Maybe Graham, if you want to contact me, we can talk about it I could ask you a few questions. Okay, I want to. I don't think I'll be able to answer that directly here now. Okay. Okay. Now, any more questions? Anybody want to jump in and speak out loud? Okay. Let me see if I can do a. I'm going to do a quick poll just to get an idea. Actually, no, I won't bother with a poll. I'm sure it'll make a mess of it. But what I would like you to do, I'm just going to ask if I can get a show of hands. I'm going to ask you to raise your hand if at the moment right now, if you think that on the balance of probability that you probably will go ahead, or you're thinking seriously about going ahead with a photovoltaic system in the next, potentially in this wave. So we're talking about going forward, getting it done in the month of February. So if I could ask people to raise a hand if you think you're just to get a feeling for it. And like, as I say, I'm quite happy people who are not quite sure yet may do it, may not. That's not a big deal. But just so I can get a feel for where we're going, because obviously the more people we have involved, the better it is in terms of the, well, I won't say the pressure we can put on installers, but there's more. Installers will make a better effort in terms of their prices if there's a larger number. Now, one thing I will say, okay, there's 25 people with their hand up there. Okay, that's cool. That's good. One thing I'll say about the installers is, I do recommend that we don't go for a single installer. Typically, the last time out we had 2 installers. If we even went with 3 or more this time out, and again, this is coming back to the idea of why I like that people will be contacting installers themselves, because it is important as well the feeling you have with the installer. It may not all come down to a price, a question of price, going for the cheapest system. So often just for the peace of mind, for the comfort, for like if a neighbor has said to you, we went with this guy, he was brilliant, whatever went wrong, he was always there, that's and if you want that peace of mind, then, and if you're happy to pay, maybe €1,000 extra, maybe €1,500 extra, it's worth it. It's like not everybody goes for the cheapest of everything the whole time, So even in that case, like what I'm saying is, let's say as the Solar Meitheal group of the 27 people or 30 people or whatever that actually go forward, maybe 30 of those will be going through the 2 installers we've chosen or the 3 installers we've chosen, and the other people may be going through. There may be 2 or 3 other installers that have come out that are just getting maybe 2 or 3 installations. We can still, as part of the Meitheal, we can still have all that kind of make sure that those other installers are aware of the kind of costs. So there is a little bit of control of costs, and also the idea of being available for any questions that may arise. If the installer, we had a good few questions in that respect when the installers actually came out doing the work and they started talking to the homeowners. And using kind of terminology that wasn't necessarily that clear, and saying, "Oh, you might need this and you might need that," and before you know it, the person who thought they were getting a simple installation, you don't get the feeling that suddenly it's become very complex. That's kind of where I come into the mix to make sure that it's that we understand that everybody understands what they're getting into. Now, let me see over here. Nitrate is a must if you have an EV with PV topping up the EV on a good day. Well, from a cost perspective, again, it's coming down to the EV being a big battery. Like I'm saying, like we're talking minimum on the market now 45 kilowatt hours. So from the figures I was given there, like if you had a if you had a 6 kilowatt PV system on a very, very sunny day, you'll be producing about 40 kilowatt hours. Okay, so on the best day of the year, you won't fill your tank of your EV. Okay, so just to kind of put that into perspective, like I think nitrate is always an option that is there. And as you say, PV topping it up, absolutely. You can have your car plugged in during the day, and you'll be getting some of it. Obviously, like most people aren't using the 400 kilometers every day in their EV. People are using like 60, 80 kilometers a day. And then you could potentially think about getting quite a part of that from your photovoltaic panels for a decent bit of the year. Okay, Noel Cronin. The ground mount systems, are the dimensions flexible or is it a fixed X by Y frame? I'm pretty sure they're flexible. Like it won't be, the systems that I've seen are, like it wouldn't be, let's say if you're going for 12 panels, it wouldn't be one panel high and 12 panels long. They remain pretty much rectangular. But there is, I guess that's exactly what you're saying. They're narrow enough but longish. 3 banks of 4 panels. I would say that's doable, yeah. Yeah, I would say that is because we are talking, kind of rectangular there. Yeah, so to answer your question, it's not fixed. There is flexibility. These are basically profile metal or aluminium, which is then bolted into each other. So it can be worked out different ways. Okay, Aaron is asking, should we do the external insulation wrapping before or after the PV? Okay, well, let's look at it a couple of different ways. The time taken for the installation, the roofers will be on the roof for half a day, pretty much half a day. It's done and dusted. And then your electrician, the electrician is going to come in, he's going to run the wires, and that again will be a half a day. You've got, like, if it's a battery and an inverter, you're flexible enough on that. So I would say that it wouldn't necessarily have an impact on whether you get the installation done before or after. Because again, your external installation will have a huge impact on your heating requirement. Photovoltaics is not really in the same game in terms of the heating requirement. Okay, so I don't think there's an issue there. The one thing to look into there, and actually this comes back to the heat pumps as well, you need to look into the grants that are available. In some cases, like I say, with the photovoltaics, you need to get your for the photovoltaics, you need to get a certain improvement on your BR to get up to a C3. That'll be true as well for your external installation, and that'll be true also for your heat pump. The heat pump, I think, needs to get to a B2 for the grant to be allowed. So it may be necessary. You would need to look into that. Now, I mentioned, Jason, I was talking to you about that last week. It's not that clear. I was asking more and more direct questions to SEAI, and I haven't gotten a clear answer back from them yet. The idea being the sequencing, to make sure from a grant, for getting the best bang for your buck in terms of getting grants, you may need to look into the sequencing. Aaron, I'll have a look at the external installation side of things as well, okay, for that, and I'll include the information once I get the definitive information back from SEAI. I'll include that as well, okay. Now, Noel, the ground mount frame kit. If you go on to that site that I'd given you, Solartricity, they have 2 kits on there. They have one which is, I think it's called the K2 system. And let me get back in here. If you go into the Solartricity site, products, mounting systems, and then there you've got the K2, and you've got I think it's called the tree system or something like that. Hang on, let me find out where it's gone. I've got too much on the screen. Yeah, in the ground mounting systems over there. Yeah, you've got the K2, you've got the tree system. Tree system, the advantage there is that you don't have a concrete foundation. Okay, you basically hammer at an angle metal bars into the ground. And then you've got what they call the console system. Basically, they're like big plastic buckets that you put concrete blocks into. And then each one of these buckets will be for 2 panels or something like that. And then you work out your installation that way. The advantage there is that there's no civils to be done. There's no trenches to be dug. There's no, except potentially for your cabling, but there's no concrete to be poured. Maybe leveling off the ground a bit. But those systems, I don't think they'll give you prices there directly. I think you need to ask them for a quote for those 3 systems, okay? But they are the ones that it was. I know that the guy in East Clare who was doing it went with the K2 system. Okay. Okay, Irene. Yes, the point of the grant. I'll have a look at that. Okay, you were thinking from the point of view of the grant. Yeah, that makes sense. Okay. How long is the payback on the larger 6 kilowatt system with a hot water inverter and a battery? using 5.5, so your 6 kilowatt will be producing that for you. Let's just do it off the top of your head, off the top of my head. So if we're saying we had a 10K, it cost about 10K. Let's say it's 11. It's going to cost us 11, right? If you're using 5,500 units a year at the moment, if we're saying it's costing you 20 cents a unit, that's costing you 1,100 euros a year in electricity, something like that. And if you're going to be generating roughly 5,400 units, then that's the value that you're saving. So your payback would be, you're talking about a 10-year payback. You know, it's costing you 11,000 euros and you're gaining about 1,100 euros a year on that. So that's what you're talking about. Okay, considering a battery 2-to-1 split between day and night. Now, obviously, on a 6 kilowatt system, obviously you're going for a battery there. Again, then it depends on how complicated you want to get. You know, because if you want to get into doing, if you're doing 5.5K already, your system will generate all of that. Now, there may be high load days during the winter where you're not generating enough, you know, because even if we're saying over the course of the year it'll generate 5,500, which is the same as your annual usage, there will be times during the summer where you'll be exporting to the grid, and there'll be times during the winter where you'll be consuming from the grid. But when you're consuming from the grid, you know, if you get the inverter that will allow you to do that forced charging of your battery at night, so that you can fill up your batteries at night even though there's no solar, and then use that night rate electricity during the day. So that will have an impact as well. Like the payback thing that I gave you there, the 10-year payback, was probably a little bit simplistic. Oh, hang on, sorry, did I say 10-year payback? If you're getting a grant, then you're down from 11K down to 8K. So it's no longer 10-year payback. It's a 7-something year payback. Okay, so that's depending if you're getting a grant or not. Okay. Okay, no grant, yes. Okay, sorry. Back to the 10 years then. Right. Okay. Any more questions coming in there? Okay. Is it possible to skip the inverter using the PV to divert to hot water system? See, the thing is, your hot water system uses AC. It uses the 220, the grid. That's what it works off. Okay. If you're able to get a DC one, then you could think about. I've never seen it done. I'm sure electrically it's possible to do. I've never seen it done. You know, the inverter is what turns your electricity from your panels into the kind of electricity that anything in your house can use. So, yeah, I can't. Yeah, I've never seen it done. Okay. Now let me just see if there's any questions that I missed there. Okay. Well, I can see from all the questions that are coming in, and like from the number of hands up there, like obviously we have a bunch of people who are interested in going ahead. So I suppose the goal this evening was to give you a few more questions that you need to go and answer, to think about, to get the information about your energy usage, maybe with a little bit more understanding of the costs that we had there, understanding a little bit of where maybe you're going in a year's time, if you're going to buy an electric car, if you're going to go for a heat pump, or if you're going to work on, another thing to keep in mind is the idea of reducing your energy requirement. And when you understand your energy load, that's where you can start thinking about, again, the best investment. If you want your bang for buck, invest in using less energy. That is the best way of getting a return for your money, whether that's to do with heating or whether it's to do with the electricity in your home. Okay, that's pretty straight up. Now, one thing I'll mention again then is the notion of, we talked about businesses earlier on, I talked about the community grants. There's a community scheme with SEAI called the Sustainable Energy Communities. Okay, I'm just going to give you a link to that as well, okay? Because it's something like there's a bunch of them being, okay, let me get the link up here before we get on there. Because if you're in a business and if you're interested in, or if you're in a community group and you've got a community building you want to get, and you want to get improvements there, the Sustainable Energy Communities, let me get to the ground there. Search our network map. Okay, there's the map. Basically, SEAI provides mentoring support for community groups. So there's a lady called Lorraine Power who works with SEC, who will facilitate, kind of upskilling meetings for the communities, understanding what grants are available, understanding the way of working that SEAI recommends. You can get for communities, you can get an audit done at the level of the community. It's called the Energy Master Plan. You can get one of those done. And all of that, for example, the Energy Master Plan at a community level is 100% funded by SEAI. And what we'll see is, so on this page, I'll stick this link up here for you for anybody who is interested in on that aspect. And maybe you'll see that there is an SEC already created near you, in which case you'll have a contact name there. Otherwise, it may be something that you get the contact names on that website. So maybe it could be interesting to connect to Lorraine Power about that. Now we just have a little bit of a network. Okay, here we go. South Clare, apply. Okay, so we can see we've got one in Liston Varna, Milton Malbay, O'Brien's Bridge, Kilkee, Clooney, Spansel Hill, Doolin, Inannis, Diamond, spread around the place, Newmarket. Okay, just something to keep in mind if you're from a more community aspect. Okay. Now, any more questions? Any more questions out there? If there aren't any more questions, or while you're thinking of your next question, the idea now is to go away, get more information about your energy usage, understand the idea about financing, have a look at your roof, get more comfortable with what it potentially could be. Get in touch with me if you have specific questions. We can have a chat about, I can have a look at your roof there. We can talk about, we can have a chat and see what would or what will or will not work, in reality. So the idea being that we now take a few weeks to do that. Now, in those few weeks that we're doing that, I'm also going to be updating my website so that you'll be able to put in the information about your installation, about your needs into the website, just from a management point of view of managing the group. And that should be in place in a week or two. So I'll be getting back on to you, asking you it'll be just basically putting in like the air code and your email address, the same things I had already, but also as we go through step by step of saying you've gotten your BER, what was your BER level, and what other kinds of, once we get through to specing the sizes if you're going for a hot water diverter, so we can publish to everybody saying we can see these are most people are going for this size, or most people are or are not going for this size battery, just to be able to share the information there. So I'll be getting back to you in the next couple of weeks about that. On that topic, if anybody knows a Python Django developer, if those words mean anything to you, I'd be very interested in speaking to that Python Django developer. Okay. All right. Now, let me see, with a couple of what is required if placing panels on two different roof orientations. Well, basically what you're doing is you're splitting up your production times. Instead of having just a single orientation where it's at this time of let's say if you're southwest facing, that at 4 o'clock in the afternoon, that's where you'll be getting your peak output. If you split it between an east and a west roof, then you'll be getting a kind of one little peak in the morning and one little peak in the evening. So it's more the time shift during the day. That's what happens. Obviously, the ones, if your panels facing east will not be producing that much in the evening and vice versa. So it does have an impact. But as to what's required, there's no particular requirement. From an electrical point of view, it's not a big deal. Nothing much to manage. Okay, will most PV systems allow usage of batteries when the mains power is down, or does that require additional isolation from the grid and extra cost? That comes down to a couple of things. It comes down to your inverter. The inverter can do the isolation, can take care of the isolation side of things so if there's any extra cost, it's just making sure that your inverter can do that. Not all inverters can do it. Some of the cheaper inverters will not do isolating from the grid. So that is something to put in as a kind of as a requirement when you're speccing the kind of inverter that you need. Okay, again, the inverter is the brains behind the system. So sometimes it can be a good idea to, whatever about the panels, because panels I consider them to be commodities. They all pretty much work the same. It may be worth the while giving a little bit more buck for the inverter, just in terms of the in terms of the different functionality that it can provide, okay? Okay, now, should we send our energy data to your good self? Let me see. Okay, I think it's probably better if we maybe have a chat rather than just sending me data, okay? It's probably better that we take 10, 15 minutes and have a discussion about it, and then we can share the information at that point, and then I think that's the best way of working at it, okay? Okay. I think, yeah, I'm sure at this stage people have other things to be doing, okay? So let's take it that that this is where we are. Time to go away and think. If you've got more questions, come back to me by email or on the forum. Remember, I'll send out a link in the email again. We do have a forum where people can ask questions, and it's better just from a knowledge sharing point of view. You might find somebody who's already asked the same question as you have, okay? So that's we'll do it on the forum as much as possible. And otherwise, we'll work towards, throughout the month of November, getting people towards the end of November where they say, yeah, I understand where I'm going. I understand roughly what the costs will be. I'm happy to go ahead, and then we take it into December, and then we go out to tender. Okay? So, listen, thank you very much, everybody. We've gotten to step 2. This is good. Again, another thing on step 2, if you have other people that are interested in joining into these webinars, let them feel free to come in and join in. Whether they want to go forward or not, that's no issue. Okay, that they can join in and be part of it and ask questions, whether or not they go ahead with the installations afterwards or not. Okay. Thanks very much, then, everybody. Bye bye.